Okay, so we're going to move on to the next section, which is solving trigonometric equations. And we're going to be looking at our graphs quite a lot again for this one here. So let's have a look at a question. Question might look like this. So solve sine of theta equals a half in the interval from 0 to 360 inclusive. So what do you actually have to do? Well, what you need to do, let's just check. Yeah, we'll draw one here. Is this question is asking you, when does a sine graph, or more precisely, which angle, which number of degrees, when you put it into a sine graph, will give you an answer of a half? Now, hopefully you know this one, or at least you know one answer for this one, based on the previous videos. We said 30 in a previous video. 30 degrees. If you do sine of 30, you'll get a half, and you can just check that for yourself now if you like. But the problem with that is this is 0. This is 360 degrees. If you extend the line of a half over, you can see actually there's more than one answer. And we need to use these rules from before, okay, to help us. So if I know that 30 is 1, in fact, if you do on your calculator inverse sine, so if you do this one, inverse sine of 1/2, your calculator will say 30. So how do you get the other one then? Well, sine of 30 is the same as sine of 180 minus 30. Well, 180 minus 30 is 150. So in other words, you need to do 180 minus. We need to look for values between 0 to 360. Well, a quick sketch shows you that it doesn't happen again until 390. So actually, we're finished. That's it. So we can get 30 as our first answer. This is called the principal value, okay? But we also then need to find the other one by doing 180 minus. So let's do another one, okay? Tan. So with tan, it's going to be a good idea to do a graph. So something like this, okay? So from minus 180 to 180, well, that's quite a big spread actually. Could we, maybe it'd be better to use our sketch from before. Let's use our sketch from before. So there we go, minus 180 to 180. Well, remember, it just keeps repeating. So if I want the left-hand side sort of has this shape as well. So I want everywhere, in fact, I think that's a bit confusing. I want everywhere between 0 and 180, and then I've also sort of got it again. So what this is going to mean is that I get the values here multiple times. In fact, I think I want a better graph before we do this question. So let's just do y equals tan of x. And let's change this one here to degrees. And we'll go from minus 180. We'll go from minus 180 to 180. Let's have a look at that there. That's better. So I think we'll be ready to answer it once we've got something like this in front of us. So let's just check the question first of all. So solve 5 tan theta equals 10 in the interval minus 180 to 180. So that's quite a big domain. That's why I was just getting that picture of a graph. The thing is, we're not actually ready to solve this yet. If you noticed before, you need to do, sine cos of tan to the minus 1 of the answer to get your first value. But it's not 3 sine to the minus 1, it's just sine to the minus 1. You need to get the tan theta bit on its own first of all. So the first thing I'm going to do is divide by 5 both sides. So tan theta divided by 5 by both sides is equal to 2. Okay, so then if I do tan to the minus 1 of 2, that's how I'm going to get my first answer. And what I'm probably going to need to do is I'm going to need to think about whether I need to add or take away 180. So let's just find that first answer. So 63.4. Okay, 63.4. Now let's look at it on the graph. So 2, we were looking at tan of 2. Well, here's 2. So 60, whatever it was, 63, I think it was. That was that one there. But remember, we were looking for between 100 minus 180 and 180. Now, on the diagram, you can see quite clearly where the other answer is. It's over here, isn't it? Okay. And how do we get that? Well, we would do 60 equals 63.4. And then this distance here, there's 180 between them. So we take away 180. But you wouldn't want to necessarily need to get this diagram each time to do that. So how could you work that out? Well, the only rule about tan is that you add and you take away 180. So if you did 63 at 180, well, it's too big for this value here. So you would know that it's wrong. If you did 63.4 take away 180, and you get this value here, minus 116.6, you can see that it fits within this domain here. Okay, domain means sort of like the x values. Okay, the x values is called domain. So that means that it's correct. And we're only expecting 2 answers here. So number 1, number 2, and we're finished. Okay. Bit more difficult. Let's try some again. Bit more difficult. 0 to 360. So just worth doing a quick sketch here. Now it's not ready. It's not ready because there's a number in front of sine. So you need to get rid of that number. So I'm going to divide by 2 both sides. So sine of theta equals minus a half. A half is about 30. So, you know, I'm expecting a number here like 210 and so on. Minus a half. If we draw that line, we're also expecting 2 answers. So let's just double check. So there we go. We get, so interestingly on this one, the calculator will give us minus 130 apparently. So why is that a problem? Well, that's a problem because it's not between 0 and 360. In fact, it's quite far away. So it might be a good idea to just add 360 to it straight away. If you did that, you would get 330. Or you can still do this 180 thing. It works with double negatives as well. So if you do 180 minus and then minus 30, you get 210. And in fact, that's both of the answers. So for one of them, we need to do the 180 minus thing. And for the other, we need to do the add-on 360. And we get both of our answers here. From our graph, we know what we're kind of expecting. And we know that's it. Okay, so 2 values will do it. It's 210 and 330. Now one more. So it's got sine on this side and it's got root 3 cos. Now, do you remember your exact values? Because if you do, you're going to have a better intuition for what to do here. Root 3. What is root 3 about? Well, actually, it's about tan. So that's the clue. And here, because you've got sine and you've got cos, it's not obvious really what to do because these are 2 different graphs, 2 different functions. But if we divide both sides by, let's say, cos, what would we get? On the left-hand side, we would get sine theta over cos theta. Then we would be equal to root 3 of cos theta over cos theta. Sine theta over cos theta, well, that is tan. So tan theta equals root 3. Again, if you know your exact values, you're more likely to spot that. So we do tan to the minus 1, which is the inverse tan of root 3. Notice it says 0 to 360. So depending on our answer, we're going to add or take away 180. So we get 60 degrees. We know that we can fit another 180 in there, up to 360. So we do that. We get 640. If we took away 180, we get minus 120. That would work. If we added another 180, it'd be 420. It's way too big. So we know we're finished. 2 answers. Okay, so have a quick go at those ones there on the board, and I'll just reveal them in a second. So get the 2 underneath, inverse cos. Pause the video if you haven't already, because I'm about to reveal it. Okay, and we get 30. Don't forget the rule. The rule for cos is cos x is equal to cos of 360 minus x. So 360 minus 30 is 330. Same again, pause the video, have a go at this one here. Okay, I'm assuming you've done that now. So divide both sides by cos. Will give you 1. This will be tan theta. Get the tan theta on its own, so divide both sides by root 3. So you get 1 over root 3. Again, if you know your trig values, that's a big giveaway. 30 is what you will get. If you add on 180, it won't fit, 210. So it must be take away. 2 answers. Okay, and that's it for sort of solving the more basic equations.